All right, so standard deviation can be a confusing subject at first. Hopefully, this will make it simpler for us. Standard deviation, basically, when we have a data set, we want to be able to know where that data set's going to fall and then where we can expect a particular data point to fall within that data set. So standard deviation gives us the distribution of that data within a data set. So simply put, I'm a big baseball fan, love baseball. Average baseball, 9 inches to 9.25 inches diameter, 5 to 5.25 ounces. That's standard for Major League Baseball, youth baseball, all around. So how we could look at this is we want to know if our baseball falls within a certain set of standard deviation. So when we look at a standard deviation chart, and I don't know how hard this is going to be to see, but you're going to have either a small deviation, which is going to create a tall, narrow curve, or you're going to have a large deviation, which is going to create a wide, flatter curve. The wide, flatter curve would tell us that, so for instance, in the baseball, we're going 5 to 5.25 ounces. If we had a 6 ounce difference that we were working with, we would expect to see that wider, flatter curve. But with a very small data set that we're working with between 5 and 5.25 ounces, we expect that data set to be really tight, really tall, where our median is right in the middle. And our standard deviations would be smaller. So we're talking about, eighth and 16th of an ounce differences. And so we would expect within that, whenever we look at our deviation within our data set, that all of our baseballs are going to fall in this 99.7%. Anything else we would reject as not falling within there. So all the way over here, we have our 5 ounce. All the way over here, we have our 5.25 ounce. And then we can break down smaller and smaller and smaller until right here should be our median. So we'd be looking at about 5 1/8 ounce, 5 1/16 ounce, somewhere in there. And so standard deviation is going to tell us most of our baseballs, 99.7%, are going to fall within this range. We can break that down even further. We know that 95% of our baseballs are going to fall into this area here, and 68% are going to be in that really tight tolerance right in the middle. That's what we would consider to be like a perfectly balanced ball within the range that we have issued. Well, why is this important? Because in the early 2000s, there was a big all of a sudden jump in home run hitting, and people were going with what's called a juiced ball theory. So the way they understood it was sales were down, interest was down, baseball was overall down in the 2000s. People were more interested in the NBA, the NFL at that time. So why would collecting this data and finding out what it means be important? Well, there was actually a researcher that went down to Costa Rica to, I believe it was Rawlings manufacturing facility, and he wanted to know, is it true that they're juicing the balls? Are the balls somehow completely different? So when you look at a baseball, you can't really tell a lot about it by just looking at the outside, right? Usually there'll be, stamps or marking that tell you what it's made of, who made it. Is this an official ball? Is this a practice ball? Is it a T-ball? So what he should expect to find is a cork or rubber innard, wool or yarn wrappings, leather outside, 108 red stitches, 2 stitches hidden inside the ball that you can't see, V-shaped stitching, just a baseball, right? So when he went down there, he started collecting data. What is the size? What is the consistency? What is the material used for each individual layer of the baseball? Found that they were no different than any other time period since the American League, National League merger and the baseball rules being merged together. So what someone who believed in the juice ball theory would expect to find a skewedness in the data. So instead of just finding just our regular basic bell curve where we're going to have a median is equal to the mode and median, and it's all spread evenly across the data set, they were expecting to see something more like this, where the data is skewing one way or the other for particular balls. So you would see, youth baseballs would look like this, but Major League baseballs, they were expecting to see either lighter balls, so the data skewed to the left, or heavier balls, data skewed to the right, that would then affect the hitting. So once the researcher got down there and went through all his stuff and then looked at the balls that were in use in Major League Baseball, he decided that there was nothing in the data set that would confirm that there was any validity to the juiced ball theory. And how he was able to come to that was by doing statistical analysis and figuring out what the standard deviation and distribution along the curve was. And so that's a real quick, practical way that you can understand standard deviation and why it's important. Thank you.